Welcome and thanks for joining us. My guest today is Patrick Sullivan. He's the Chief Technology Officer for Security Strategy at Akamai. Patrick, good to have you with us.
Good to be here, Tom.
And Akamai is one of the legacy internet services companies, really. And it might be useful to understand how you have evolved from simply the delivery network and all of that to the posture you have today in today's internet.
Yeah, absolutely. So, Akamai, went public in the late 90s, right at the peak of the dot-com boom. I think the first thing that Akamai is known for is speeding up websites, right? So in those early days, we built out a network of reverse proxies all over the internet. So we're in 4,200 locations, more than 1,000 ISPs, and really got started, speeding up the delivery of websites by having that proxy very, very close to end users. And I think that what we found over the years was that's really a sort of an optimal platform upon which to build security, right? So we talk about edge security or SASE, but I think we sort of found our way into this because as a reverse proxy, when our customers were attacked, obviously we were taking that hit first. So for us, early days was around mitigating DDoS attacks, and we saw some really spectacular DDoS attacks targeting the US federal government. And sort of what we found was the sites that were on Akamai stayed up and those that were not, unfortunately, had a rough time. So we had a unique capability. And then over the years, we've expanded, to sort of be the leader in web app and API protection. We've been a big player in zero trust access and then, continue to expand the security offerings. So, roughly Q1 of next year, we anticipate that security will be our largest line of business, overtaking, everything we do with streaming and speeding up websites.
All right, so that's a good overview. And I think we want to get into the whole idea of cloud computing. This is where the federal government is clearly has gone to a great degree. And as they have, the way they approach it in terms of the technical makeup of applications and cloud services has really changed. We've moved from just simply hosting and using communications wires to get to the application hosted in the cloud, then the virtualization era. And now we're really into this whole segmentation, containerization era. Tell us what the trends are and what needs to be done to secure those nowadays.
Yeah, absolutely. So I think we're certainly in the era of hybrid multi-cloud. I think most organizations are strategically pushing into the cloud as much as they can, but ultimately, I think what that looks like in 2022 is there's still some workloads that are going to be in a legacy corporate data center or a colo, and that may be legacy or that may be strategic there for the long term, and then obviously pushing into cloud. I think over time we find most organizations, even if they have a preferred partner, you end up with more than one cloud provider. So you end up with that hybrid multi-cloud type of architecture. And I think to your point around segmentation, one of the shifts that we see is, as you move into cloud, you have a couple of kind of design architectures, right? One that we saw in the early days was sort of the rack and stack, right? Where you would consider your cloud architecture, by looking at what you did in your data center historically and just try to replicate the same thing. And if you had a box that performed a function, maybe you would buy a virtualized analog to that in the cloud environment. And then obviously the counter to rack and stack is more of a cloud native type of approach where you look at the unique capabilities of the cloud and kind of revisit some of those design assumptions and say, we don't necessarily need to do it the way we always have. There may be some opportunities to gain better advantages of this architecture. And I think segmentation is one of those areas.
And just describe what it is and what effect it has on the perimeter, because security is changing from that perimeter model to defense in depth, which is giving way to zero trust, correct?
Exactly. Yep. So you still will have some perimeter, DMZ, whatever you would call that. But I guess the shift is rather than having sort of a soft GUI center in that network behind that DMZ with the assumption that that perimeter will perfectly protect you and nobody will ever compromise that perimeter. As you said, we now see the rise of sort of that zero trust architecture, and really where software-based segmentation fits into that is hardening that internal network, and we get all the way down to what we would call microsegmentation. So, really what this gets into is, if you're on a workload, what is the reachability, across the network there, right? And we really try to get to that zero trust model where you restrict that only to the paths that are required. So, for example, you could have a database workload that's running in a container or some other form factor, and you could understand that really only the Mongo process on that workload needs to contact a web server, and that may be the extent of the communication that's required there. So you restrict that in that case really, really tightly, because often a database is crown jewels type of information. There may be other workloads that are more permissive. A load balancer would have more reachability, for example, but you make those decisions in a very deliberate way based on least privileged communication paths.
Right. And so the motivation of the hackers is still either a database or data information that they want to get for whatever use they might think they have of it. And also sometimes to disrupt service on websites, to stop applications like the old, DDoS type of thing, flood them, whatever. And so how does the segmentation then affect the way you approach security, with the understanding that it's still the web services or the data that the hackers are after?
Yeah, exactly. So you still need to protect that front end, right? So if you have a web front end, which when we look at the data breach investigation report, that's the most likely area to be compromised. You still need to harden that for that perimeter communication. But then behind that, essentially with microsegmentation, you can restrict those communication paths. So even in the worst case scenario where an attacker gains a foothold on one workload, maybe a web server, for example, they're very, very much limited into what they can do to go forward. I think what we see when you look at breaches, usually there are somewhere between 2 and 5 steps that attacker must complete to have a successful breach. So really the thought there is, even if you have that first compromise, segmentation would limit what an attacker can do going forward, make it much, much more difficult for them to get to their ultimate target.
And so the security measures, where do they live then? Are they a cloud service? And how do you architect it such that wherever those containers, wherever those segments are operating in a multi-cloud hybrid environment, that you make sure that they are protected?
Exactly. And I think that's the big shift with software-based segmentation. So traditionally, in a network, segmentation would often be a task assigned to a firewall of some sort. So you bring traffic to a firewall, and then based on VLANs or some network-based concept, there would be a decision of permit or allow. Where the security exists in a software-based segmentation model is right there on the workload. So as you have a container, when it spins up, part of the build process would be an agent that's created. And then rather than having security policy based on network constructs like a VLAN, the policy is based on cloud native concepts like we would call it a tag. And you can have multiple tags. So that web server we spoke about would have a tag for its role being a web server, its environment potentially being production, and then several other tags would be possible, including dynamic tags such as things that we can query that workload to understand, is it vulnerable to the SSL v3 risk that was socialized earlier this week? Is it running SolarWinds? In which case we have to potentially implement some policy there. So all of those type of things can be considered, because you are shifting that east-west inspection from a firewall down to the workload, where you have a much deeper understanding of the process that's making the request across that corporate network.
So in effect, each service carries its own security with it, you might say.
That's correct. Yep. The security decisioning would be made right there on the workload, sort of in its own host-based firewall model.
And you mentioned dynamic tags. Are there also static tags or permanent tags that stay around?
Absolutely. So things like the role or the environment. If it's a web server, that's a tag that would persist. If it's a production environment, that's a tag that would also persist. So there are some of these things that you would want to do programmatically, other things that you would assign on a manual basis.
And I'm presuming each tag and each measure that's spun up and then maybe put aside when the application might wind down for the night. That's not something that's done by hand by an operator at a console, is it?
Exactly. You're exactly right. So I think that's one of the things, if you move to that cloud native environment, or if you have container orchestration, you're going to have containers that are being created, being destroyed. And the nice part here is you don't have to go bring them into a particular VLAN or assign a network policy. Wherever they spin up, that policy could be inherited as part of that build process.
And as containers communicate with one another to create application services, because you're really combining these microservices into creating something tangible that fulfills the mission, the APIs become a point of security concern. Tell us more about that.
Yeah, absolutely. So I think, on that, business to consumer perimeter, we have a very unique insight into global traffic. We see about 5 billion HTTPS hits per minute. 90-something percentage of those hits are APIs these days. We certainly live in an API world, and APIs carry all of the risk that you would see with, a traditional GUI web exposure. So there's always the risk of DDoS, as you said, and we're certainly seeing more state-affiliated DDoS this year due to geopolitical tensions. You have the risk of sort of the OWASP, type of attacks, command injection, or other imperfections or vulnerabilities in the code that somebody wants to exploit on that customer-facing exposure there for the application. But then APIs have their own attack surface, right? So there's a whole different, the OWASP, the list of top 10 vulnerabilities is slightly different for an API than it would be for a web attack surface. And I think a lot of that is just due to the more direct exposure of business logic that you see with those APIs, right? So some of the things you have to keep in mind there are, the number one mistake that people tend to make is just failure to authenticate. We're seeing a lot of these APIs, as you said, with microservices, can be spun up very, very quickly. And often there's a lack of visibility within the security team to the existence of those APIs. And if you're not careful, you could be exposing sensitive information. That's sort of the most common scenario we see with APIs, that they were built and exposing a bit of business logic that really should be kept internal. And an attacker gets a hold of that, and they don't have to work very hard, right? If they find that, in some cases, it's trivial to pull the information down.
So then with respect to security, you don't have operators pushing buttons and looking at blinking lights so much anymore. What is the administrative task then? How does the cybersecurity staff, your security operations center, or your NOC staff, how does their life change in this new model of the way, let's say, administering cybersecurity?
Yeah, absolutely. So I think the key, as you said, there's sort of this explosion of microservices, right? You empower your developers in a sort of an API-based architecture, and they can create these APIs very, very quickly. So I would say the primary challenge for the security team is visibility, understanding where all of those APIs exist. Hopefully you've got a good governance process so that security has a chance to review and be aware of any endpoint before it's exposed. But I think what we see all too often is that governance breaks down and an API gets published that security may not be aware of, and that SOC may not be tracking that. So that's kind of the first gap that we try to help people close, is visibility into APIs, and then prioritization of those APIs. Is there an API that we see sensitive data traversing, as opposed to maybe a lower risk API where we don't see sensitive data being exposed? So all of those things would help the SOC with that first challenge, which is visibility and awareness of those API endpoints.
And the implication there is, as you implied earlier, that the security measures are shifting to the left higher in the development, or sooner rather, in the development chain, because the containers have to carry their own security provisions. And so when you're developing them, that's when you build them in, and then you make sure people understand that they exist.
Exactly. That's the name of the game. Yep. I think shifting left, as you said, to have a chance to keep up with the pace of development. I would say also, more consolidation of control. So I think what we see now is the rise of what's known as the WAAP, the web app and API protection platforms that give you a comprehensive set of controls there on that API perimeter, not just from DOS and OWASP attacks, but potentially from the threat of bots that are making up more and more of the requests that we see out there on the internet.
And does this lessen then the need to worry about, say, a particular threat vector? For example, phishing attacks, and you have vulnerabilities that are opened up from inside the organization. When you have less of a perimeter, hard model, soft inside of the old days, and more of security going with each microservice, then that seems to lessen the importance of worrying about vectors.
Yeah, so I think we would say, you certainly want to mitigate as much of that risk as you can of phishing or that initial access. But I think that risk is, at best, there's sort of an asymptote approaching zero. You'll never drive that down to zero. So you do your best effort, do the best you can, but you'll never get it all the way down to zero. But then the assumption is, even in that unlikely event where there is that initial access, that doesn't have to be devastating, doesn't have to be catastrophic. I think the classic model that people use for microsegmentation is the cross section of a submarine or a ship. You design the hull to be as robust as possible, and you hope and pray that you do everything you can to prevent anything compromising that. But if you look at naval design, there's always compartmentalization beyond that, so that even in that worst case scenario where there's a compromise of the hull, it doesn't have to be catastrophic. You can restrict the exposure to a limited area of that of the vessel. So same model. You want to have that segmentation as fine as possible, so that even when you do have that, ultimately, I think inevitable initial compromise, it doesn't have to then be a catastrophic event for you.
Well, let's bring this all around then to what Akamai actually offers to enable people to have this level of security, this distributed security, this container-based and API-looking type of setup.
Yeah, absolutely. So for us, we're sort of leaders in that WAAP, protecting the web app and API attack surface to prevent that initial attack. And we're also fortunate to be leaders in the newly emerging zero trust segmentation space, shifting that east-west protection to more of that software-based model, where it can be done in a more programmatic and ultimately that zero trust model where you understand the context of communication patterns between your workloads and restrict traffic only to explicitly required communication paths, as opposed to the classic implicitly trusted because you're on a corporate network type of a model.
And is there a so-called pane of glass by which someone can see all of this? Where does that live, and who should be looking at it?
Yeah, absolutely. So to your point about shifting left, certainly we would have dashboards where you could see all of these things, what's happening with your API and your web attack surface, what's going on with visualizing the dependencies of these applications. We also certainly want to integrate with SOAR platforms, SIEM platforms, so that you can see that alongside other things. But I think to your point about visibility for the east-west, that microsegmentation, the visibility is a key. I think few organizations that haven't embarked on sort of a zero trust project have really the level of visibility into what is calling what within the organization. It's pretty common for us to kind of move through a zero trust segmentation project and end up with a 90-something % reduction in lateral movement attack surface, by restricting those communication paths down to only the explicitly required paths. Tremendous reduction in attack surface. And then one of the tools that we do offer for somebody to get their head around, what their risk level may be, we have a tool called the Infection Monkey. So you can use that as sort of an attack simulation. It's on GitHub. You can download that, and it's basically has a benign payload, but you could use that to basically simulate an attacker gaining a foothold on a particular point within your infrastructure. You deploy the monkey or multiple monkeys and see where all can get within the organization to give you a sense for, what is the risk should somebody, work their way to have a privileged point inside of our corporate network. So that's available open source if somebody wanted to take a look at that.
So you can be your own black hat and white hat, or good guys, bad guys type of thing right within your own organization.
For sure. Yeah. And if you have a red team, they could make use of that,
Mhm.
just to kind of simulate, some of the steps that somebody would take, and give a sense for what that risk would be, should somebody gain that initial access through one of the ways that people do so.
All right. Well, a very good overview of the modern approach to cybersecurity. Let's thank today's guest, Patrick Sullivan. He's the Chief Technology Officer for Security Strategy at Akamai. Thanks so much for being with us.
Thank you, Tom.
And I'm Tom Temin. You're listening to Federal News Network. Let's go back to the studio now for more on the Industry Exchange Cloud.